This is Lecture 5, Making Basic Comparisons. By the end of this lecture, you should be able to create and interpret a cross tabulation and create and interpret a mean comparison table. A cross tabulation table allows you to use simple tables to analyze the statistical relationship between two variables. It is most useful when you have nominal and ordinal level dependent and independent variables. Recall that both nominal and ordinal level variables separate observations in your dataset into different categories. To demonstrate how to use a cross tabulation to analyze the relationship between two variables, I am going to use the following hypothesis. Women are more likely than men to identify as Democrats. The independent variable in this example is gender, male-female, while the dependent variable is party identification, Democrats/Republicans. Gender influences party identification. Note that both of these variables are nominal level variables as they put observations into different categories and the categories have no inherent order. Now imagine I wanted to determine whether there was in fact a real-world relationship between gender and party identification. I could conduct a survey and ask respondents their gender and their party affiliation. Here is a hypothetical data set that could come from such a survey. There are 10 hypothetical respondents, 4 females and 6 males, and 5 Democrats and 5 Republicans. So, were women in the survey more likely to identify as Democrats than men? We can use a cross-tabulation table to find out. To set up a cross-tabulation table, the first thing you need to do is write the dependent variable name in the first column's heading. Then you write the categories of the dependent variable in the rows below. Then you add a total row at the bottom. Then you write the independent category names in the subsequent column headings. And last, you add a total column at the end. So in our example, since party identification was the dependent variable, we write party identification in the first column heading. Then we add Democrat and Republican labels in the rows underneath, as they are the category names for the dependent variable. Then we add a total row at the bottom. Next, since our independent variable was gender, we add the labels male and female to the subsequent column headings, as they are the categories of the independent variable. Then we add a total column at the end. After we set up our cross-tabulation table, we have to count how many cases from our dataset fit the criteria for each cell. So for example, in this first cell here, we have male Democrats. We would go to our dataset and look for how many cases fit this criteria. As you can see, there were 2 male Democrats. Hence, in the male Democrat cell, I wrote the number 2 in parentheses. In the second cell, we have female Democrats. We would go to our dataset and look for how many cases fit this criteria. As you can see, there were 3 female Democrats. Hence, in the female Democrat cell, I wrote the number 3 in parentheses. We would complete this process for each cell. After you input the correct information in each cell, you then have to calculate column totals and row totals. The first column total is calculated by summing all the observations in that column. In this case, it is 2 plus 4, which equals 6. In the second column, it's 3 plus 1 equals 4. Then you go to the last column and calculate row totals. So in the first row, 2 plus 3 equals 5, and in the second row, 4 plus 1 equals 5. Then you can calculate the last column total, which is 5 plus 5 equals 10. After you calculate the total number of cases in each cell, you have to calculate cell percentages based on the column totals. The cell percentage is calculated by taking the total number of observations in a cell, dividing that number by the total number of observations in the cell's column, and then multiplying that value by 100. So in this first example, The male Democrat cell would be 2 divided by 6 times 100, or 33.33%. The male Republican cell would be 4 divided by 6 times 100, or 66.67%. And then the last cell would be 6 divided by itself, 6 times 100, which equals 100%. You continue this process for the subsequent columns. And this is what your cross tabulation table should look like. In order to interpret the cross tabulation table, you must compare cases across the same value of the dependent variable. Many students forget how to do this, so it is really important that you remember this. Otherwise, you will not know how to interpret your cross tabulation. In this case, I would compare males and females in the Democrat row only. 75% of women supported Democrats, whereas only 33.33% of men supported Democrats. It does seem as though women are more likely than men to support Democrats. So we can conclude that women are more likely than men to be Democrats. In the cross tabulation table, 75% of women were Democrats, while only 33.33% of men were Democrats. We can repeat this process for other values of the dependent variable. In this case, I would compare males and females in the Republican row only. 66.67% of men supported Republicans, whereas only 25% of women supported Republicans. So we can conclude that men are more likely than women to be Republicans. In the cross tabulation table, 66.67% of men were Republicans, while only 25% of women were Republicans. A mean comparison table allows you to use simple tables to analyze the statistical relationship between two variables. It is most useful when you have a nominal or ordinal level independent variable and an interval or ratio dependent variable. Recall that both nominal and ordinal level variables separate observations in your data set into different categories, while interval and ratio level variables are continuous. To demonstrate how to create a mean comparison table, I will use the following hypothesis. Dictatorships spend more on defense spending as a proportion of GDP than democracies. Note that the independent variable institutions is a nominal level variable, dictatorship/democracy, while the dependent variable defense spending is a ratio level variable, as it is ordered and continuous. Now let's say I wanted to determine if there really was a real-world relationship between institutions and defense spending. I could collect data on type of institutions in a country and how much that country spends on defense as a proportion of their GDP. Here is what a hypothetical data set of that type of data would look like. To set up the mean comparison table, you put the independent variable name in the first column heading. Then you put the independent variable category names underneath it. Then you add a total row at the bottom. Then you write the dependent variable name and the term mean score in the subsequent column heading. So in this example, since institutions was the independent variable, I put the term institutions in the first column heading. Then I wrote democracy and dictatorship in the next two rows underneath, as they are the categories of the independent variable. Then I made a total row at the bottom. Last, I placed the term defense spending mean score in the subsequent column heading. Next, you calculate the average of the dependent variable for each category of the independent variable. The average is the sum of all cases for the dependent variable in one category of the independent variable divided by the total number of observations in that category. So for the democracy category, the calculation would be 0.05 plus 0.03 plus 0.02 and that value divided by 3 for 3 observations. Hence, the average defense spending as a proportion of GDP for democracies is 0.03. For the dictatorship category, the calculation will be 0.15 plus 0.08 plus 0.10, and that value divided by 3 for 3 observations. Hence, the average defense spending as a proportion of GDP for dictatorships is 0.11. In the total row, you find the overall average of the dependent variable for all observations. The calculation is 0.05 plus 0.03 plus 0.02 plus 0.15 plus 0.08 plus 0.10, and that value divided by 6 for 6 observations. The average for all observations was 0.07. Next, you count the number of observations that each category of the independent variable had and write that number under the mean score for the category in parentheses. So the democracy category had 3 observations. So we write the number 3 in parentheses under the mean score for democracy. The dictatorship category also had 3 observations. So we write the number 3 in parentheses under the mean score for dictatorship. And there were 6 total observations. So we write the number 6 in parentheses under the mean score for all observations. One way to interpret the mean comparison table is to compare the mean values of the dependent variable between the categories of the independent variable. So in this case, the mean defense spending as a proportion of GDP for democracies was 0.03, while the mean defense spending for dictatorships was 0.11. It does seem like dictatorships spend more on defense than democracies. We can conclude that dictatorships spend more resources on defense spending on average than democracies do. On average, dictatorships spent 0.11 of their GDP on defense spending, while democracies only spent 0.03 of their GDP on defense spending. You can also compare the mean values of the dependent variable for each category to the overall mean of the data. So in this case, the mean defense spending as a proportion of GDP for democracies was 0.03, while the overall mean was 0.07, indicating that democracies spent less than the overall average on defense spending. So we can conclude that democracies spend fewer resources on defense spending than the overall for all countries. On average, democracies spent 0.03 of their GDP on defense spending, while for all countries they spent 0.07 of their GDP on defense spending. On the other hand, the mean defense spending as a proportion of GDP for dictatorships was 0.11, while the overall mean was 0.07, indicating that dictatorships spend more than the overall average on defense spending. We can conclude that dictatorships spend more resources on defense spending than the overall average for all countries. On average, dictatorships spent 0.11 of their GDP on defense spending, while for all countries they spent 0.07 of their GDP on defense spending.